Hi, you guys. Today I have problem 5.31 from Young and Freedman's University Physics textbook. I've been in such a weird mood today. I don't feel like doing anything. I haven't really done anything productive except like clean today. I just feel so lonely and the heater smells like home. So I decided to do this physics problem to cheer myself up. I hope you find it just as enjoyable. But yeah, if my voice is off today, that's why. A box with, actually, before we get started, please don't forget to like and subscribe. Thank you so much for watching. A box with mass 10.0 kilograms moves on a ramp that is inclined at an angle of 55 degrees above the horizontal. The coefficient of kinetic friction between the box and the ramp surface is mu k is equal to 0.300. Calculate the magnitude of the acceleration of the box if you push on the box with a constant force F is equal to 120.0 newtons that is parallel to the ramp surface and A directed down the ramp, moving the box down the ramp, and B directed up the ramp, moving the box up the ramp. Okay, so what I like to do, as per usual, is let's draw ourselves a diagram. So let's draw ourselves a diagram right over here. And let's say that this is our ramp. And let's draw a box on this ramp, right? And this box, let's say, well, we're told that the mass is 10.0 kilograms. And the incline of the ramp is 55 degrees, right? Right there and right there. Okay. The coefficient of kinetic friction between the box and the ramp surface is 0.300, right? So, well, we can just write that down like this. So mu k is equal to 0.300. Calculate the magnitude of the acceleration of the box if you push on the box with a constant force F is equal to 120.0 newtons, right? Okay. All right, I think that's a little bit too thin. I'm just gonna, oh, I don't know. That's one of the thickest. Maybe I'm not pressing hard enough. Okay, yeah. So that's the information we're given in the question. So we want to figure out the magnitude of acceleration, right? So what is acceleration? When we push the box up the ramp, or sorry, down the ramp, right? And what is the acceleration when we push the box up the ramp? Okay, so let's start off with down the ramp. So the first thing we want to do, right, for part A is let's set up our Cartesian coordinate system, right? Or not Cartesian coordinate system. What am I saying? Let's just set up um our system of what's considered positive. Like let's set up our x and y coordinates and determine what's positive and what's negative, right? So with ramp problems, we usually like to make the direction that the box is going to be moving, or like the direction, yeah, that the item is moving down the ramp, that direction, we like to make that the positive x. And then perpendicular to the ramp, right? Perpendicular to the surface of the ramp, we like to make that the positive y, right? That makes sense. Okay, so now let's go ahead and let's start with, let's write down let's write down our knowns. Okay, so knowns, we know that the mass of the box is 10.0 kilograms. We know that the angle of the ramp is 55.0 degrees. We know that mu k is equal to 0.300. We know that we don't know acceleration, but we're looking for that, right? And then we know that force is 120.0 newtons, right? And we're figuring out acceleration. Okay, cool. So now if we want to find out the acceleration, we have to start off by writing down summation of forces in the x and y direction, right? And what do I mean by that? So that's not straight enough. There we go. Okay, so let's write down our summation of forces. So let's start off with Fy, right? So let's write down all of our forces in the y direction, right? So first, actually, one thing that I didn't do is let's actually like write down what are all of our forces on this box, right? I'm just looking for the color we can do that in. Let's just do it in black. Okay. So we have, force of gravity, and that's going to be going like, that's going to be downwards. That's going to be Fg, right? Then we have normal force, which is perpendicular to the surface of an object when it's in contact with another surface, right? So Fn, right? And we have our constant force that we're applying that is parallel to the ramp, and in part A, it's directed down the ramp, moving the box down. So this is going to be F. And then we also have a force of kinetic friction, right? And because kinetic friction is always going to be the opposite direction that an object is moving, right? So because our box is moving in like this direction right over here, our force of kinetic friction is going to be in the opposite direction, right? So Fk, force of friction kinetic. Okay, cool. So these are all the forces that are acting on this object. And one thing that I'm going to go ahead and do is I'm also going to note that over here we can actually, so these three forces, so Fn, and F force of friction kinetic, these kind of like align well with our coordinate system, right? So like we would just have to do like, oh, like, plus this minus this plus this, but like this doesn't align perfectly with our coordinate system, right? It's at an angle in between the two. So we can actually break this down, this FG down, to fit this coordinate system better. And how do we do that? Using components. So that's, the X and Y component. So using similar triangles, we can notice that, this is 55, and this will also be 55 degrees, right? Then this line over here, this right over here, that is going to be FG cos 55, right? And this over here, that component is going to be FG sine 55, right? That makes sense. All right, now we can go ahead and actually sum our forces together because we know all of our forces that are acting on this box, plus we also have them like align with our X and Y coordinate, right? With our X and Y coordinate system. So Fy. Well, first we want to notice that in the Y direction, the forces in the Y direction, they have to be equal to 0, right? Well, how do I know that? I know that because if Fn and this component didn't cancel out with each other, then we'd have the box. Okay, so my laptop just crashed and I freaked out a little bit, but I was able to recover, I think, the first part of the video that I already recorded, and I'm just going to continue from here and edit this in. That's why the writing might look a little bit different. if you're watching from this point forward, it like, yeah, you know what I'm talking about. Okay, anyways. So I think the last part that was recorded was that Fy, um, we know the summation of Fy is 0, right? And we know that it's 0 because Fn and the component of Fgy cancel out, right? And how do we know that? Well, we know that because this box isn't jumping up and down, right? It's like at rest, which means that, this force and this force are canceling each other out. Okay, so let's write that down. My laptop better not crash or else I'm done. Okay, so Fn, right, because that's in the positive y direction, minus, right, because this is negative, that's downwards, Fg cos 55 is equal to 0, right? Now let's do the same thing in the fx direction. I feel like I explained it way better before my video crashed or before my laptop crashed, but whatever. Okay, so in the fx direction, let's write down the summation of all of our forces. Well, in the fx direction, what is the net force? Well, the net force is just mass times acceleration. It's not 0, right? Because this box is like moving. It's starting at rest and then it's speeding up, which means that there is some net force acting on it, right? And we're just going to call this net force mass times acceleration, right? But like what makes up like what are the summation of forces in the x direction, right? So we're going to write that down. Well, in part A, we know that it's directed down the ramp, moving the box down the ramp, right? So we have F, right? Because that's in the positive direction. So we have F, okay? And friction is in the opposite direction of the F direction because, friction slows things down. So minus F, Fk. And in the same direction, we also have, so in the same direction as the F direction, we also have this component of gravity. So that's plus Fg sine 55, right? All right. So now we are trying to figure out what acceleration is. What is A? And we can use these two equations to help us know what is A. All right, so now let's get to actually solving. We want to figure out what A is. So we know that mass times acceleration is equal to F minus Fk plus Fg sine 55, right? And we can sort of simplify this a little bit. So F, we can keep it the same just because we have our value right over here as 120, minus FFK. So minus FFK, that's going to be mu K times Fn, right? And then Fg sine theta, that's just, we can't really simplify that further, other than that's like mg. I guess, yeah, we can write that down. We can say that this is just ma is equal to F minus mu K Fn plus mg sine 55. All right. So if we plug in all of our values, we have m. We're trying to figure out what a is. We have f. We have mu k. We don't have fn, right? We don't have that right over here. So how do we find fn? Well, we have fn right over here. We can use this equation. And this equation says that 0 is equal to fn minus, actually, I'm going to use a different color just so that it's a little bit easier to follow. Let's use mint. Okay. So we know that 0 is equal to Fn minus Fg cos 55, which means that Fn is equal to Fg cos 55, right? So we can sub in this term right over here because we know that FG is just mg, right? So let's do that. Okay, that's not nice. A little bit better. Okay, so let's sub that in to our equation. So again, we have m a. Let me just make sure that my microphone's on. Okay. Imagine it wasn't. I'm not recording this video again. Okay, so MA is equal to F minus mu K FG cos 55, right? Plus mg sine 55. And if we want to figure out what A is, right, we just divide both sides by m, and we end up with acceleration is equal to F minus mu K FG cos 55 plus mg sine 55 over m. All right, let's plug in our values. I'm gonna try to do that right over here. Okay, and I'm gonna do it in a different color again, so it's sort of easy to follow. Okay, let's try yellow. Or no, let's do like a light blue. I feel like that might be fun. Okay, so acceleration is equal to 120 minus 0.3. FG is just mg, right? So FG is equal to mg, and that is just 10 times 9.8. So 10 times 9.8 is 98. So 98, oh, ew, that was not. 98, 98 cos 55, right? Plus m 98, right? Sine 55, right? So this, and then divided by m, which is 10, right? So acceleration, plug that into your calculator, and I'm going to plug it in one more time just to double check. So we have 120 plus 98 sine 55 minus 0.3 cos 55 divided by 10. I'm not getting the answer that I got before. Okay, let me just plug this in one more time. 120 minus 0.3 times 98 times cos 55, okay, plus 98 sine 55. Okay, perfect. And then divided by 10. Yeah, I'm getting the answer that I got before, and that also matches with the back of the textbook. And I'm getting that the acceleration is 18.34 meters per second squared. So that is the magnitude of the acceleration when the box is pushed with a force of 120 newtons directed down the ramp, moving the box down the ramp. Okay, so now for part B. So for part B, I'm going to go ahead and erase everything except the diagram, parts of the diagram. Actually, I'm going to erase this. I'm going to keep the knowns though, because the knowns don't really change, right? Okay, so now let's go back to part B and like reevaluate the problem. So now what is it asking us? Now it's asking us, let's use green actually. Okay. So now we're doing directed up the ramp, moving the box up the ramp. So remember how before we were using like F is down, like down here? Now, no. Now it's going to be the opposite. So I'm going to erase this. Now F is going to be moving up the ramp. So let's do, or we can use green because we changed that. So F is directed up the ramp and moving the box up the ramp. And if the box is moving up the ramp, then that means force of kinetic friction is going to be moving, down the ramp because it's working in the opposite direction. Okay. And you may have noticed, or you obviously noticed, that I just erased the coordinate system that we set up, right? Because you have to set up a new one for this part of the question. So now we don't want positive to be like, we want positive to be the direction that the box is moving, right? And yeah, and now the box is moving in the opposite direction. So let's say that this is positive X and then this is positive Y, right? And we're gonna just repeat the exact same problem. We're gonna write a like a summation of forces statement, right? Exact same way, just with our like new setup, right? So again, the summation of forces in the y direction is going to be 0, right? Because again, the box isn't moving up or down. And that is just positive Fn and then minus Fg cos 55, right? That makes sense. And then again, mass times acceleration. And that is going to be, so F, right? Because this is in the positive direction now, minus FFK. And this is also going to be minus because it's in the opposite direction of F. Okay. So minus FG sine 55. Okay. All right. So now we just want to isolate and solve for A. Let's do that. And I'm going to use pink again. Okay, so MA is equal to F minus force of friction, which is mu K Fn minus Fg sine 55, right? I'm just gonna double check because I always make like little plus minus mistakes and I don't want the entire video to go to waste because of that. So positive, yep, minus force of friction and then minus, yeah, that makes sense. Okay. And we're going to divide both sides by, oh, no, acceleration. That's what we're isolating for. So divided by m, right? Divided by m. So acceleration is equal to F is equal to mu kFn minus Fg sine 55 over m, right? Now, remember how Fn, we said we're just going to pull out from here because Fn, I'm write that in purple so you can recognize it easier. Fn is equal to Fg cos 55. So we're going to make that substitution, right? Acceleration is equal to F minus mu K F G cos 55 minus Fg sine 55 over m, right? And now we're just going to plug in our values and we're going to calculate what A is. Okay, so so 120 minus 0.3 FG is going to be what 10 times 9, 9.8, so 98, right? Cos 55 minus 98 sine 55, right? And just divided by m. And acceleration is equal to, I'm going to plug this into my calculator just to double check and make sure that I get the same answer again. So it's kind of like triple check. All right. Yeah, so I'm getting acceleration is equal to 2.29 meters per second squared. And that's also like consistent with the textbook solutions and what I got earlier. So there we have it. That is going to be the magnitude of acceleration when the box is pushed with a force of 120.0 newtons directed down the ramp, moving the box down the ramp. All right, so I hope that was helpful, and I hope I'm able to like stitch the two videos together. Um, if this is helpful, please don't forget to like and subscribe. Um, uh, thank you so much for watching, and see you next time.